All right, so example 4 in this book introduces us to the idea of what's called the unit circle. Okay, a unit circle is a circle of radius 1 centered at the origin. So if I'm at the origin and I go all the way to the right 1 unit, I'm going to be at the position 1, 0 ordered pair. If I go straight up, I'm at 0, 1. If I go straight left, negative 1, 0. Straight down, 0, negative 1. Every single point along the edge of this circle is going to have a radius of 1. So if I'm looking at this triangle they've given me, it says angle theta has a measure of 60 degrees. So this is a 60-degree angle right here. That's 60 degrees. And they're curious about this point right here that's on the edge of the circle. So we have this 60-degree angle in standard position. So our initial side, let me doctor that up with some segments here, or some rays. Let's make it blue. And let's make it a little thinner. Here we go. So if I look at my standard position here, I've got my initial side is there, and my terminal side is here. That's my angle in standard position of measuring 60 degrees in this picture. Okay. It says the terminal side of this angle intercepts the unit circle at the point x comma y, and they want to know the ordered pair that represents x comma y. So all I have to do to figure this out is I have to figure out this number x, this number y, and then as far as the ordered pair is concerned, which direction am I going? I'm looking at ordered pairs. If I get a point going that way and that way, I'm going right positive, up positive. If I'm going this way left and this way up, I'm going left negative, up positive. If I go left and down, I'm going left negative, down negative, right and down, right positive, down negative. So you'll figure out the x and the y using 30, 60, 90, or 45, 45, 90 properties like we did a couple days ago. But then you'll have to establish signs based on direction. Where are you going? All right. In this case, I'm going right, I'm going up, so I'm getting a positive value and a positive value. My concern is this triangle here, so if I'm going to pull that triangle out. So imagine this is drawn in your book. What's going to be drawn on my paper is that triangle. So here's what it looks like. I'm going to draw a triangle with a 60-degree angle and a 30-degree angle. And I know they're a 60 and a 30-degree angle because I marked them that way. Do not get a protractor out, just kind of draw it right. All right? The base here is x, and the height is y in the picture. What's the hypotenuse? How long is the hypotenuse?
Y.
X squared equals y squared.
I said it a minute ago. How's it 1?
The radius of the circle.
It's a radius of 1 circle, right? So this distance from here to here is 1 because it's a 1 radius circle. So that's 1. If you recall from a few days ago, we talked about 30, 60, 90 right triangles in addition to 45, 45, 90 right triangles. They have relationships, right? And the relationship of sides, the ratio of sides here is a 30, 60, 90 triangle has a ratio of 1 to the square root of 3 to 2. That's the ratio of sides in a 30, 60, 90. What I told you to do was put an x, put an x, put an x. So each of these things here corresponds to each of these things here, right? And the correspondence has to do with their position amongst the angles. So a 90-degree angle goes with 2x. The 90-degree angle here is opposite 1. A 60-degree angle goes with the square root of 3x. The 60-degree angle is here, it's opposite y. The 30-degree angle goes with 1x, and the 30-degree angle here is opposite x. So in the 30, 60, 90 triangle that we have, we know one measure. We know the hypotenuse. The hypotenuse matches up to 2x, so I'm going to write 2x equals a hypotenuse length. Which means that x equals, divide by 2, 1/2, right? So we divide by 2, just basic algebra there. Once you know what x equals, 1 times x and the square root of 3 times x will give me these two sides here. 1x square root of 3x, 2x. 2x equals 1, x equals a half. 1/2 times 2 makes 1, right? There's my three sides. So this side equals 1/2 times 1, which is 1/2. This side equals the square root of 3 times 1/2, which is the square root of 3 over 2. So we're just finding those missing sides in the 30, 60, 90 right triangle like we did before. That represents how far I'm moving horizontally, how far I'm moving vertically. And again, I'm moving to the right, which is positive. I'm moving up, which is positive. So my ordered pair that represents this point here is the point 1/2, comma, the square root of 3 over 2. Let me throw a second problem up here just to make sure that we all get this. Suppose the angle they gave me, instead of 60-degree angle, you can work this in the same position, maybe put like a little box inside the box or something to segregate the problems a little bit. You can draw on this picture though to have the picture we're looking at. Suppose instead of theta is equal to 60, they gave us theta is equal to, let's go with 225 degrees. So 225, 0, 90, 180, 270, so 225 is right here. So this is my theta now, which is 225. Okay. Now I'm going to draw a vertical line to the x-axis like so. And I need to know the reference angle here. In the first quadrant, the reference angle was the standard position angle. But in the third quadrant, if you recall, the third quadrant, the given angle equals 180 plus the reference angle. The given angle is 225. If I subtract 180, I'm going to get 45 equals alpha. So this is a 45-degree angle here. I'm trying to find the ordered pair here, x comma y. X is how far I'm moving horizontally, y is how far I'm moving vertically. All right, I'm going to go a little bit bigger here. I'm going to put all my work right here. So I want to draw a picture of that triangle. So I'm going to draw it just like this. I'm going to draw it just like it looks on my paper here. 45 goes there, 45 goes there, 90 goes there. This is x, this is y. What is this hypotenuse? It's 1 again, right? Because we're still inside the unit circle. The radius is still 1. The radius is always 1 inside the unit circle, so hypotenuse is going to be 1. Again, our task is to figure out what x and y equal and then represent it as an ordered pair based on which direction we move. So the ratio of sides in a 45, 45, 90, 45, 45, 90 triangle is 1 to 1 to the square root of 2. Again, if I just assign an x to each of those things, right? Just like the other problem, 90 degrees goes with square root of 2x, 90 degrees goes with 1. 45 degrees goes with 1x, so 45 degrees goes with, let's say, y. 45 degrees goes with 1x, so 45 degrees goes with x. You find the angle, go across the triangle to find the side. The side we know, hypotenuse, matches up to the square root of 2x. So I'm going to have the square root of 2x equals 1. Move that over here a little bit. Square root of 2x equals 1. If I divide both sides by the square root of 2, I get x equals 1 over the square root of 2. And we know that we can't leave square roots in the bottom. We've seen this quite a bit now, so let's make sure we're fixing that every time we see it. Multiply top and bottom by the square root of 2. We're going to get the square root of 2 over 2 is equal to x. So 1 times x, 1 times x. Those are the two sides we don't know. This side is that side, so x equals square root of 2 over 2. This side is that side, which is this side, so that's also the square root of 2 over 2. So we're going square root of 2 over 2 this way, square root of 2 over 2 that way, going left, negative, down, negative. So the ordered pair in this problem is negative square root of 2 over 2, comma, negative square root of 2 over 2. And we're trying to find the ordered pair representing that point. Make sure you put the right signs to go the right direction. If you put positives there, you're going positive square root of 2 over 2, positive square root of 2 over 2, you end up right here instead of over there. You're going the right distances, just not the right directions. So that's the idea. To find an ordered pair on the unit circle, that's all you have to do. Use the reference triangle. Reference triangle will either be a 30, 60, 90 using these ratios, 45, 45, 90 using those ratios. You will know the hypotenuse because it's a unit circle, always 1. Your job is to find the legs and then write your ordered pair based on the directions.